explorers are sending back terrifying data to Earth. The Explorer-1, NASA's farthest traveled rocket, is still traversing uncharted regions of the universe nearly 50 years after its launch. Specialists are baffled by the unexpected data that this historic space probe is sending back to Earth due to what appears to be a malfunction. Join us as we examine the strange information that the Explorer has been transmitting during its delicate space exploration adventure. Analysts have long been fascinated by studying space, ever since the Big Bang, which inspired the launch of Explorer-1 and Explorer-2, among other space missions. Explorer-2 was actually the first spacecraft to launch, departing from NASA's Kennedy Space Center on August 2, 1977. On September 5 of the same year, Explorer-1 was launched about 2 weeks later. However, how did they switch places? As twin probes, both weigh approximately 720 kilograms, the equivalent of a small car. They were launched during a rare planetary alignment that created a slingshot effect, propelling the spacecraft from one planet to another. However, they had to travel at different speeds and in different directions. On December 15, 1977, Explorer-1 was able to overtake its identical twin en route. Since then, it has been our primary tool for uncovering various mysteries of space. Explorer-1 was the first spacecraft to accomplish this when it began its Jovian imaging mission in 1978. At that time, it was nearly 265 million kilometers from Earth and sent back thousands of photographs. In January 1979, Explorer-1 completed an extraordinary 108-hour observation period, capturing 3,750 images of Jupiter's rotation. These images were compiled into a time-lapse video showing 10 full rotations of the planet. In February 1979, it traveled through Jupiter's moon system, and a month later, it discovered a faint ring around Jupiter. Explorer-1 also made a remarkable discovery when it identified 2 new moons, later named F and Enos. To prepare for its flyby of Saturn and avoid potential collisions with Titan, one of Saturn's moons, careful adjustments were made. During its orbit of Saturn, Explorer-1 discovered 4 additional moons: Mimas, Enceladus, Tethys, and Dione. After completing the Saturn mission, scientists decided to end the planetary exploration phase of the mission and send both Explorer-1 and Explorer-2 beyond our solar system at a speed of 325 million kilometers per year. In January 1990, the mission was renamed the Voyager interstellar mission. One of the most iconic images in history, a family portrait of the solar system, was captured by Explorer-1 on February 14, 1990, while it was 6 billion kilometers from the Sun. A total of 60 images were taken, bringing the spacecraft's total photographic count to 670. However, Mercury and Mars were not visible in these photos due to various factors. To conserve power and memory, the spacecraft's cameras were turned off before its journey into interstellar space. In addition to the interstellar probes, NASA also operates Pioneer 10, Pioneer 11, and the New Horizons spacecraft. Before Explorer-1 surpassed Pioneer 10 on February 17, 1998, Pioneer 10 held the record as the farthest spacecraft. Explorer-1 continued its journey for 14 more years before finally reaching interstellar space on August 25, 2012. With no other space probes in sight, NASA did not publicly announce the milestone until 2013. By November 2018, both Explorer-1 and Explorer-2 had officially exited the solar system, with Explorer-2 crossing the heliopause and entering interstellar space. Explorer-1 is currently believed to be 145 billion miles, or 550 million kilometers, from Earth. It has continued to provide groundbreaking data that no other mission has been able to collect since it entered the unexplored regions beyond our solar system. However, scientists have recently detected strange anomalies in its performance. Explorer-1 is now sending back confusing signals to Earth, suggesting that it is uncertain of its own coordinates. There is, however, an unexpected twist. Typically, scientists have pre-programmed Explorer-1 to enter safe mode or send an alert if it deviates off course, but so far it has not done so. Additionally, its antenna, which transmits data back to Earth, appears to be functioning perfectly. Yet, the information it has recently been sending is garbled. The interstellar probe is still operational, receiving and executing commands from Earth, and transmitting scientific data. However, readouts from its navigation and control system do not accurately reflect what is actually happening on board. According to an official NASA statement, something unusual is occurring within the spacecraft. Each interstellar probe, including Explorer 1 and Explorer 2, carries a 12-inch gold-plated disc loaded with audio and video messages in case an extraterrestrial species discovers the spacecraft. The disc includes 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim. These recordings, often referred to as the Space DVD, are stored in 55 different languages. If an alien species were to discover the probe, they would likely attempt to decipher the messages. While some speculate that the spacecraft might be under alien control, scientists have dismissed such theories. Explorer 1's ability to function relies heavily on its attitude and orientation control system, which keeps its antenna pointed toward Earth so that researchers can receive its transmissions accurately. Mysterious signals from the edge of space. As scientists at NASA's Jet Propulsion Laboratory, JPL, continue analyzing the perplexing signals from Explorer 1, they grow increasingly puzzled. The spacecraft is still transmitting data, but the readings from its orientation and control systems remain inconsistent with its expected behavior. One of the strangest anomalies is the sudden fluctuation in its power levels. Despite the fact that Explorer 1's nuclear power generators should be gradually losing energy in a predictable pattern, recent telemetry suggests erratic voltage spikes, almost as if an unknown force is interfering with the spacecraft's internal systems. Even more unsettling, Explorer 1's onboard instruments, which have been faithfully recording interstellar radiation levels, cosmic dust density, and magnetic field variations, have started transmitting data that doesn't align with any known cosmic phenomenon. Readings suggest that the spacecraft has encountered a region of space where the expected laws of physics appear to be shifting, an area where electromagnetic waves are bending in unusual ways, and radiation levels are fluctuating unpredictably. NASA engineers attempt to troubleshoot the issue by sending corrective commands, but something strange happens. Explorer 1 acknowledges the commands, executes them, and then reverts back to its inexplicable behavior. It's almost as if the spacecraft is following an unseen set of instructions that NASA never programmed. A new discovery or an unsettling possibility. Some researchers speculate that Explorer 1 might have entered a region of space that has never been studied before, a part of interstellar space where exotic particles or unknown forces are at play. Others propose a more controversial theory. What if the probe has encountered something artificial? Deep in NASA's archives, a few scientists recall an old theory, one that was dismissed as science fiction decades ago. Some astronomers once hypothesized that certain regions of deep space might contain technosignatures, evidence of advanced extraterrestrial technology. Could Explorer 1 have stumbled upon something unnatural? In a bold move, NASA prepares to send a new series of commands to the spacecraft, hoping to gain more insight. They instruct Explorer 1 to reorient its cameras, dormant since 1990, toward the source of the anomalous signals. If the cameras can still function, they might capture something unprecedented. As Mission Control waits anxiously for a response, a new data packet arrives from the spacecraft. The telemetry confirms that the cameras have successfully reactivated, but the images themselves remain encrypted due to the spacecraft's outdated systems. Engineers scramble to decode them, racing against time as Explorer 1 drifts farther into the unknown. Then, suddenly, without warning, Explorer 1 goes silent. The final transmission. For the first time in decades, no signal is received from the spacecraft. NASA engineers frantically attempt to re-establish contact, sending repeated transmissions into deep space. Hours turn into days and days into weeks. Then, just as hope begins to fade, a weak signal emerges. It's garbled and barely intelligible, but one thing is clear. Explorer 1 has sent one final transmission. What it contains will change everything we know about space. Besides data, it controls how the space apparatus is situated. Architects watching over the situation currently feel that the attitude control system is functioning as it should, which only adds to the mystery we currently face. Moreover, none of the security features designed to protect the rocket from danger have been activated. According to Susan Dodd, project manager for Explorer 1, such a mystery isn't all bad. Right now, in the Pioneer mission, the shuttles are both around 45 years old, which is much older than what was envisioned in the mission plan. Dodd also acknowledges that the spacecraft's engineering team will face significant challenges in resolving the issue with Explorer 1 due to the vast distance between us and the spacecraft. The challenges are immense, primarily because the rocket is approximately 14.5 billion miles from Earth. This enormous distance presents numerous difficulties that the team must navigate carefully. A rescue operation is nearly impossible given the current technological and strategic limitations. Explorer 1 is far beyond the reach of any spacecraft or repair mission that we could feasibly send. The spacecraft's astonishing journey has taken it to the farthest regions of our solar system and beyond into interstellar space, where it continues to travel farther away from us every day. Messages sent from Earth at the speed of light take nearly 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team takes considerable time to be received by the spacecraft. This delay presents a significant challenge for troubleshooting and analysis. Furthermore, once Explorer 1 processes the command, any response or data it sends back to Earth will take another 21 hours to return. This suggests that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it particularly difficult to implement operational solutions or iterative troubleshooting processes, which are often essential when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating various scenarios and potential outcomes. Unlike missions closer to Earth, where experts can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Each instruction must be meticulously designed to address the known issues without causing unforeseen problems. Given the extended time it takes to confirm whether a command had the intended effect, the critical communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Every command sent must be accurate and successful, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are transmitted to Explorer 1. Despite these fundamental challenges, the spacecraft itself is over 40 years old, having been launched in 1977. While the technology on board was cutting edge at the time, it is now considered outdated by modern standards. The engineering team must work with hardware and systems that were designed and built in the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant wear and tear on the spacecraft systems. Explorer 1 has been exposed to intense radiation, extreme temperatures, and micrometeoroids for more than 45 years. These factors contribute to the degradation of its components, making maintenance and repairs even more challenging. Despite these obstacles, the engineering team remains committed to resolving the ongoing issues. They are investigating various theories about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is crucial given the high stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also utilizing the built-in redundancies of Explorer 1 systems. Like many other space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems and restore normal operations if they confirm that a specific component is failing. Summary: while diagnosing and resolving the issues with Explorer 1 presents immense challenges, the engineering team is leveraging their expertise, experience, and the spacecraft's inherent durability to address them. Their careful and patient approach is crucial in managing the critical communication delay and the complexities of working with a spacecraft that is both extremely distant and quite old. Despite the odds, their efforts aim to continue Explorer 1's legacy of exploration and scientific discovery, far beyond its original mission scope. The malfunctions may be the result of cosmic rays altering some of the spacecraft's delicate electrical systems. These high-energy particles, originating from distant supernovae or cosmic events, travel through space at nearly the speed of light. When they strike Explorer 1, they can penetrate its exterior and affect internal electronic components. The longer the spacecraft remains in space, the greater the likelihood that cosmic rays will impact its systems. Over time, this phenomenon can lead to unpredictable anomalies, like those currently observed in Explorer 1's telemetry data. Scientists have long been aware of the potential risks posed by cosmic rays to spacecraft electronics and even human astronauts. However, the extent of their impact can be difficult to predict or mitigate. Despite these challenges, engineers have implemented various measures to protect spacecraft from cosmic rays, including shielding sensitive electronics, designing redundant systems, and using error-correcting codes in data transmission. Even with these safeguards, cosmic rays can still pose a threat, especially to spacecraft operating in deep space for extended periods, as is the case with Explorer 1. Although the current anomalies in Explorer 1's data are puzzling, they are not entirely unexpected given the spacecraft's age and its prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze the data received from Explorer 1. They are working to determine the exact cause of the anomalies and develop strategies to mitigate their effects on the spacecraft's operations. A legacy of exploration. Despite these challenges, Explorer 1 has far exceeded its original mission expectations and continues to provide valuable insights into the outer regions of our solar system and beyond. Its achievements stand as a testament to the ingenuity of engineers and the dedication of the team that has supported it for over 4 decades. Explorer 1's journey symbolizes humanity's enduring curiosity and determination to explore the uncharted depths of space. As we look to future missions, spacecraft like Explorer 1 will continue to inspire and expand our understanding of the universe.